So continuing with our discussion on spatial information systems, they have gained in widespread attention and use in recent time. The technology can provide many benefits to the users. However, the effectiveness of the technology depends on how it is being implemented. The successful spatial information science are implemented according to a structured process that assures that the end product will meet the user's needs. It is a standard IT implementation process adapted to the spatial characteristics and challenges of spatial information. It comprises 5 basic phases, which we have discussed in our previous discussion. These 5 basic phases are planning, requirements, design, acquisition, and development and operation. Individual and group implementation of wide variety of spatial information sciences. There is no doubt that a GIS or spatial information science is a powerful tool for creating, managing, analyzing, and using the geospatial data. They are very effective with their usage, which we found in implementing any research project depending on the geospatial information, geospatial data. As such, it can provide users with many benefits and also enable data analysis and manipulation that were previously not so easy. I mean to say that these spatial information, since they are in digital format, the analysis and manipulation have been quite efficient and quite easy. So in this section, we would discuss the spatial information science planning and implementation areas. So the project design, where I would say that spatial information science project design is identical to any plan needed to solve a problem or fill a need which is existing in the real world. Here we offer some examples for providing framework for your discipline specific projects. The project design can be planned following on some basic stages. So first, I would say to formulate the objectives. Now these objectives needs to be crisp and clear. So what you can do for formulating objective? First, you need to identify the problem. So first stage would be identification of the problem. Examine the data of different time period. Find the changes in over time. What are the attributes where changes have been observed? Does you find any trend? The changes in the pattern which you have observed, does it suggest any trend that you can initiate within the identification of the problem? Another can be what are the expected outcome? That also should be think when you are setting up objective for your project. So the outcome can be the hard copy map, since we are using spatial information, the digital database, since we are dealing with digital data, some kind of statistics which would come of different attributes, information which we have incorporated in our project. There may be some reports. There can be also some decision support system, etc., that you can draw out from your research or project. Then in the objective itself, you should identify who will benefit from this project. Some individual, people, society, institutions, administrators, officials, politicians, or even environmentalists or researchers, etc. So this also need to be think about beforehand you start your project. So it will also come into the objective. Then another can be who else can use this outcome. So when you are carrying out any research project, you are putting some labor into it. So that needs to benefit others also. So within the objective, I would say we need to look also as to how and who would be using our results. The state level or national level policymakers, to begin with, if our research or if our work is so effective, then it will be the best part of it. If the policymakers are using it, or planners of the study finding, your study finding is used for planning for policy initiative at any level, local, national or regional level, and may further reflect a general trend for if you are investigating something in the academic field, that may also be the outcome of the result which you initiate for the project. These all would come into the objective part. The second stage would be the designing the database. Whatever planned project which you have conceptualized, you need to design the database for it, which is required for this project, for this work. This is a crucial stage, as the success of the project is greatly dependent on judicious and appropriate database design. I need to suggest you that sometimes we get carried away, because now we have a large number of data sets easily available in digital format. But we need to be a little judicious and use only appropriate data. Otherwise, irrelevant data may result into some kind of anomaly in our findings. So when I talk about the designing of database, it includes identification of required and optional data layers. Some would be required as basic source, and some would be the added information which you need to add into your spatial information database. What do we need to conduct the study may be the different time period data also. So for basic characteristics, attributes linked to the phenomena. So we need to be very careful when we are identifying which would be the basic information which you would be using, and what would be your attribute information which you would be adding into it. And as I am saying, that all of these needs to be specific, following the same time period data. If there is any anomaly in the time period data, then you cannot link them. So that's also very important when you are identifying the base data and attribute data. Then another can be identification of required and optional attributes. I talked about the basic, and now I am talking about optional. So what type and level of classification will be employed in your analysis? And what other attribute data we need to support our modeling for the phenomena under investigation? So these optional attributes would also be taken care of in the database design. And one important part of it would be definition of attributes and codes. What is the classification system for the phenomena? And how do we code that into the database? That would also be very critical and very important. In case of additional data to support the mapping and analysis which is being used, what would be the nature of the existing attributes? And do we need to modify them? These are essential part of database design, when we are defining the attributes and their codes. The next can be the registration of map layers to a standard base map. In all the spatial information analysis, we try to bring all the databases into one standard format, into one standard base map. So what would be the scale of an existing database, and are those scales appropriate to our mapping scale? That would be important and critical. Are the maps in the same projection and coordinate system? That is another important aspect. What is the accuracy of the digitizing process or scanning process, from where the input we are getting of these data? So all of them, they would play an important role while we are designing the database. Then another can be the geographic data encoding schemes of point, line, polygon entities. How we will represent different attributes, and most essentially the ground truth locations, etc., they are also very important and critical. And we all know that data encoding schemes are quite variable across the different softwares which we use for spatial information. So that also need to be looked into and should be in our consideration when we are looking into the database design. Then lastly, allocation of storage space. Given that the study expected to generate a digital data set consisting of many attributes, how large will be the data set and how we manage, store and preserve these data needs to be planned in advance. Now this in modern day has been somehow overcome with the system's increased storage facility, but still I would say that sometimes we face this kind of problem because these spatial information is very voluminous. For example, if we are using satellite data, these are voluminous informations, and it is not only about storing the space, but also when you want to retrieve it back for cross-checking or some other operation, then if it is voluminous, it is difficult, it takes time. The system processing requires greater efficiency. So that way this is also need to be taken care of. So in this the third stage would be database automation. The database automation for the planned project. This is again a very significant and critical stage for the success of the project. Now it also includes, for example, input data. The data input is a method of selecting, acquiring and converting data into a digital format that can be stored and analyzed in using computers. It is also known as data encoding. We have discussed the data encoding processes and procedures in detail previously. There are a number of steps involved in this process of data input in spatial information science platforms. There are many sources of data also, but following are the commonly used data sources. Therefore, different software packages are required to convert data from one to other. It involves a range of methods to convert data into spatial information science. So always need to look into the compatibility and accuracy. So when we talk about the data, input data, encoding of data, converting the data, transforming the data, we need to be very careful because these data come in different format. And we also need to look into the compatibility of these data into our system. Needless to say, the accuracy needs to be verified again and again of these attribute information, these input informations. The second and even more important would be the topology creation. The geodatabase topology helps ensure data integrity. A topology provides a mechanism to perform integrity check on our data and helps us to validate and maintain better feature representation in our geodatabase. In addition, we can use topologies model to spatial relationship between different features. So that way the topology creation is also very important and very critical. We have, again, I would say that we have discussed it at length, the concept of topology, and you might have now good understanding about it, and you would understand as to why topology is important in spatial information. The third can be the input attributes. As I am saying that we would be using many packages, software packages, and they have capabilities for inputting and drawing data from different sources. But they also have various functions to edit, store, and reshape data, which would be helpful for our analytical operations that may be used to manipulate the data into appropriate usable information, and also for appropriate output of the information which we have drawn. So there can be three distinct phases to the data input process. The first phase is the design phase. We identify, conceptually code all the needed features and attributes of our project. That would be the first phase of data input. Next is the data acquisition phase, which involves acquiring the needed data from different sources and getting it into the format that our program is compatible with. We have discussed it earlier also. I am just repeating that in this database input section in data automation, we require this to be considered. And finally, in the data capture phase, we digitize hard copy maps, and we may also directly bring data into the spatial information format. There may be transformation also into the format which the spatial information system is compatible with, that we have discussed earlier also. And also building the user interface specific to the needs of the users. The nature of spatial information science is heavily intertwined with the world of design. Maps themselves are a user interface and a user experience, serving as a visual tool to communicate and provide insight on a specific region, and subject is building the user interface. Here a user interface is what the user is actually interacting with. The user experience is everything about how the user completes the relevant workflow while in provider's digital domain, remaining within the provider's digital domain. So these are important aspects of data automation. The fourth stage would be database management for the planned project. This is equally significant and critical stage for the success of the project. As the data management power the most demanding geospatial processes with the efficient performance, scalability, and security. They also provide easy integration with other spatial information and also even non-spatial applications. It might include creation of coordinate system. So putting all the database to a common coordinate system and projection, the coordinate reference system, CRS, which you might be learning in your lab exercise, is one of the most important function of spatial information science, the CRS, coordinate reference system. It is a coordinate-based local, regional, or global system used to locate geographical features that occupy a position in space. And it allows us to analyze the geographic data using accurate locations and measurements. I would emphasize on geographic data use which have accurate location and measurements. That's one very important aspect which is related with spatial information. The second can be data tiling. Now we all know that we are representing the ground realities in spatial information, and the ground is so large, and the information which comes in pieces and parts. So joining adjacent spatial information, joining adjacent areas into database, or in some cases splitting large database into tiles and develop a management strategy for tiles. That is also quite important and relevant. So tiles are physical subset of a larger geographic area which might contain identical themes. Tiles are essential to reduce data load on computers, allowing faster computation and processing. So this is also one very important aspect of database creation, database management, data tiling. The fifth stage would be the data analysis for the planned project. This is core and most significant stage for the success of the project. We have talked at length about spatial data analysis and its advantages. We all know that spatial data analysis help solving many complex problems related to the location. Or if they do not solve the problem, they sensitize us. They make us aware as to how at any location different phenomena are evolving. We can plan accordingly. So that way the spatial data analysis is very important and critical. Through analysis, we can conduct thorough research and understand the data specifically from the geographical site. Also, we can use geospatial analysis to assess trends, make the right decisions, and predict the future trend also. So spatial analysis is the process by which we turn the raw data into useful information. And if you can see here, some of the widely used data analysis procedures, they can be overlaying, they can be buffering, we can merge, recode, the network analysis, the terrain modeling, spatial adjacency in the context of topology, and also data transformations. The data transformation is to bring value, add value to the information, and that way the data is transformed. The sixth stage would be presentation of results. Whatever we have conducted in our analysis and study, that needs to be presented effectively. This is the purpose of conducting any research, any project. The final presentation in spatial information system holds great importance. Here are some reasons why they hold importance. First would be the demonstrating excellence, demonstrating mastery. The final presentation allows us to showcase our understanding of spatial information concepts, tools, and techniques, because we are executing these understanding into our results. We are projecting these understanding into our results. It's an opportunity to demonstrate our efficient use, mastery of spatial analysis, data visualization, and also how we can use these spatial information for coming to some kind of conclusion, for problem solving, or to bring in new insight into it. The second can be communication skills. Presenting finding effectively is a crucial skill in any field. The spatial information science presentations helps us conveying complex information to diverse audience, including stakeholders, colleagues, or experts. I am saying complex information because we all know that the ground realities are quite complex, and some of the information, they may not be easily identifiable through our experience, because we are dealing with relationship. So some of the relationship which may not be appearing on the ground, but actually our spatial information analysis would bring insight into it. The third can be the real world context. The final presentation often involved real-world case studies. So our effective application of spatial information science skills to address practical challenges such as planning, monitoring or response, etc., they would be one of the outcome. Then we also need to think about feedback and evaluation. The presentations provide a chance for experts to evaluate the quality of work, and there can be constructive feedback which might help us to improve our project and refine our skills, spatial information skills. This may also result into professional development. The ability to present the spatial information results professionally is valuable contribution. Communicating effectively and present day driven insights are asset for the presentation. Now, just to sum up, a well prepared final presentation not only reflects the technical competence but also highlights the broader impact of spatial information in solving the real world problem. That is what I would say would be our objective of this particular course, where we feel that whatever theoretical and conceptual knowledge you have acquired, you should bring that knowledge into your discipline. In representing the phenomena which you are examining, add the spatial dimension in different ways and draw out some new insight into it. That is the purpose of the project which you might carry forward using your understanding and knowledge which you have acquired through this particular course. Lastly, now the learners, they are expected to execute a complete project designing right from the beginning of problem identification, generating a data model, analyzing and drawing inferences of whatever phenomena, as I am saying again and again, whatever phenomena you are familiar with or you are expert in that, you just conceptualize it. But conceptualize with adding the spatial dimension into it, and that will add value to it.